All right, welcome back to part 14E. What the question here is asking us is they want the 36-month failure rate to only apply to 10%. So 10% is 0.10. So they want what they want is everything before that fails to only be 10% of our copiers. Well, we just found out in part D that 36-month failure rate is about 19.6% of our copiers. So there's only two things that we can change in our model, and that's going to be the standard deviation or the mean. But the problem tells us they don't want to change the mean lifespan. They want the mean lifespan to still be right down the middle, which of course I can't draw a straight line on this thing. They still want the straight line to be 42 months, the mean to be 42 months. So if you can't change the mean, you can only change the standard deviation. That's why they're asking for it. All right, so what I have to figure out is what a z-score is for that area. And if I'm given an area of 10%, I'm going to inverse norm on my calculator 10% as 0.10 with a mean of 0, a standard deviation of 1. And what that's going to do, it's going to spit out a z-score when you do that. So under second distribution, you're going to inverse norm, option number 3, you are going to inverse norm 0.10 with a mean of 0, a standard deviation of 1, and you're going to get a z-score of negative 1.28. So I've got a z-score of negative 1.28. That means I am a little over one standard deviation away from the mean. Remember, a mean has a z-score of 0. All right. Excuse me. So if I know a z-score is negative 1.28, I can plug that into my z-score formula. I know that 36 months is the x, 42 months is the mean, and I need to figure out what that standard deviation is. If I go through the algebra and solve it, I know that standard deviation is going to be about 4.7 months. So what part F is asking you is to explain in words what the change in standard deviation means in this context. What that means is that if I want to make my 36 months not be 20%, but I want to decrease it to 10%, and I don't change the mean, I have to make my standard deviation smaller than they were before so that my tails, where the 10% at, is closer to the 36 than it was when it was at the 20. So what it's doing basically to our graph is it's making it tighter. It's going to make it a little skinnier. Still going to have the same height, still going to have the same mean, but it's going to make it a little skinnier.